Today we will be discussing medians and altitudes. We will be able to use medians to find missing parts of triangles. What is the median of a triangle? The median is a line segment which connects the vertex to the midpoint of the opposite side. To illustrate this point, we will look at a vertex here. To find the median, we would first find the midpoint of the side opposite it, and then draw a straight line from that vertex to our midpoint. This creates our median. Next, we will look at a point of concurrency. This is simply the intersection of all the medians in a triangle. So, to illustrate our point of concurrency, we will find each midpoint, M1, M2, and M3. Now, there are ways to find the exact midpoint using constructions or graph paper, but for now we're just going to do a rough illustration. So to get to M1, I will start at the vertex and draw a line from M1 to this vertex. M2, the same way, and finally M3. If our midpoints were plotted correctly, then they will all intersect at one central point. This is the point of concurrency. Let's highlight that. So the point of concurrency will be here, right in the center. This point of concurrency is also known as the centroid. So the centroid is the point of concurrency. It will always be located inside the triangle. Now, let's discuss the theorem of concurrency of medians in a triangle. This states that the median of a triangle intersects a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. In order to visualize this theorem, let's draw a triangle. So if the triangle is labeled A, B, C, with midpoints D, E, F, then the medians will go from B to F, A to E, and D to C. This theorem states that the distance from A to the midpoint P, or AP, will equal 2/3 of the distance from A all the way to E. Similarly, we could write that B to P will be 2/3 the distance from B to F, and C to P will be 2/3 the distance from C to D. Now, let's investigate what is the altitude of a triangle. The altitude is the perpendicular segment from the vertex to the opposite side. Or to the line that contains the opposite side. To show this definition, we will have two pictures. So from this vertex, the altitude would be a perpendicular or 90-degree line. We would have our altitude. Or in a triangle such as this one, the altitude would be the difference from this vertex to the line that contains the opposite side. The theorem of concurrency of altitude states that the intersection of the three altitudes is either inside or outside the triangles. Now remember though that altitudes are not medians. So this altitude is not a median, or at least not necessarily. Next, let's explore finding the medians of a triangle. We will find the medians for a triangle with the vertices -2, 5, so starting from the center, -1, -2, 1, 2, 3, 4, 5. Back to center, +1, 2, 3, 4, +1. Back to center, and point 2, -5. +1, 2, -1, 2, 3, 4, 5. So when we connect the sides of this triangle, we can then find the median that is the midpoint. In order to find the midpoint, we can check either the vertical distance, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The middle is halfway, so 5 steps down. 1, 2, 3, 4, 5. So my first midpoint is at 0, 0. Next, we will look at our line up here, and we could count either the up-down distance, our vertical distance, or our horizontal distance. 1, 2, 3, 4, 5, 6. 6 divided by 2 is going to be 3. 1, 2, 3. So our second median will be at positive 1, positive 1, 2, 3. Another method you can use for getting the midpoint is to use our midpoint formula. So if we start from point 4, 1, going to point 2, negative 5, I know that my midpoint formula states that my x-coordinate will be x2 plus x1 divided by 2, comma, y2 plus y1 divided by 2. So we'll combine our x terms and take the average to get our x-coordinate, and then combine our y terms and divide by 2 to get our y-coordinate. So our x2, x1, x2, x1, y1, y2. So we have 2 plus 4 divided by 2, comma, my y2, negative 5, plus my y1, 1, divided by 2. 2 plus 4 is 6 over 2. Negative 5 plus 1 is negative 4 over 2. 6 divided by 2 is 3. And negative 4 divided by 2 is negative 2. So my final midpoint is at 3, negative 2. My solutions would then be 0, 0, 1, 3, and 3, negative 2. So now let's use these tools for finding the midpoint to find the centroid of a triangle. So let's start by plotting our vertices. So the first vertice, C, will be at 1, 2, 3, 4, positive 1, 2, 3, 4, 5. A is at 8, 1, 1, 2, 3, 4, 5, 6, 7, 8, positive 1. And T will be at 1, 2, negative 1, negative 2, negative 3. So let's connect our dots. Now, let's take a moment and locate the midpoint from T to A. To do this, we can draw a right triangle, and we can either count the height or the x distance between these 2 points. So let's count down here. 1, 2, 3, 4, 5, 6. So if I want to find the middle of 6, I'm going to divide it by 2, which is 3 steps. So after 1, 2, 3, my midpoint will be right here. And notice by counting Vertically, I will get the same results. 1, 2, 3, 4 divided by 2 would be 2. So halfway, 1, 2, I'd follow my line and I hit at that same point. 1, 2, 3, 4, 5, -1. Now, let's get the distance from C to A, this time using the midpoint formula. So I have C, 4, 5, and A, 8, 1. So I take my x1, y1, my x2, y2, and I plug it into my midpoint formula. So my x's are combined, 4 plus 8 divided by 2, and I take the average of my y's as well. 5 plus 1 divided by 2, and simplify. 4 plus 8 gives me 12 over 2, and 5 plus 1 gives me 6 over 2. 12 divided by 2 is 6, and 6 divided by 2 is 3. So at 1, 2, 3, 4, 5, 6, positive 1, 2, 3, I find my second midpoint. Lastly, let's find the midpoint between C and T. Now, there is a third method for finding the midpoint of a line segment, and I'm sure that you remember using our compass. So we will start by placing one end on T and drawing an arc. We'll do this in red. All right, arc, and I'll rotate it to the other side, and another arc, and then I'll switch over to C. And in the opposite direction, I'll have an arc, and all the way over here, another arc. Where these 2 points touch, I'll draw a line. So from this intersection, all the way over to here, as best as we can. Where this hits the line will be the other midpoint. In this case, it is at 1, 2, 3, positive 1. Right? So let's get that unsightly line out of our way. And now we can use our vertices and midpoints to find our centroid. So from this point to A, from C to the opposite midpoint, and lastly from T to the third. I can see that all 3 points will intersect right here. That is 1, 2, 3, 4, 5, positive 1. And that will be my centroid. So, to summarize our steps, we first plot the points. Then, we found the midpoint of each side, the midpoint of each side. We connected these midpoints to the opposite vertex. And finally, we found the x and y coordinates. of the centroid.